Hello, everyone. Today we are in chapter 6. Chapter 6 is about discrete random variables. So we know what is discrete. It's count numbers, right? So we have random variable because random means in that case we have random chance. That's why they're using random variable. Okay? All right. Now we have a 3 section in chapter 6. So we all include center, variation again, and shape of the distribution. So basically we learned the probability distribution in these chapters. Okay, so 6.1, we have a discrete random variables. So discrete count, right? Okay, so what is random variable? It's a numerical measures or numerical measures. That means continuous, right? And count, discrete, right? From probability experiment. So it is called random because the value of variable occurs by random chance. That's why random. As I told you, or we learned before, discrete, right? Discrete. Now we have a discrete random variable. So if the outcome of experiment is count, yeah, we did that, count. Then discrete random variable. Measurement, we have a continuous, right? Okay. Measurement continuous. So we are using capital X to denote random variable. Random variable means the value of a variable occurs by random chance. Yeah, makes sense? Okay. Then we denote DRV means discrete random variable, and CRV means continuous random variable. Okay? All right, let's answer this one. So we have sum of X is the sum of a face of two 6-sided dice that are rolled. So we had the experience sum of, right? So each outcome has 1, 2, 3, 4, 5, 6. And their sum must be 11, 10. I'm thinking 7. Right? Yeah. So this is discrete, right? So discrete random variable. So let me denote. A discrete random variable, right? B, X is the number tails. Number of tails. Yeah. How many number of tails, right? So it's a discrete, right? Yeah. Discrete random variable. How about weight of rich peanut butter? Weight. So continuous. So continuous random variable. And number of spam phone call. Yeah. Number. So discrete. Good job. DE. And length of time. Measure. So discrete. Wait a minute. Oh, no. What I'm saying. Number of time measure and then discrete. Number of times discrete. No, sorry. Number of No, hold on. I'm gonna zip. Length over times, length over time, measurement, continuous, right? So CRV, F, number of students who show up to class, number of students, discrete, right? DRV, very good. Okay, so we have discrete probability distribution. All right, so I'm gonna read the definition here. So discrete probability distribution is a probability distribution that lists each possible discrete outcome along with its probability. X is a discrete random variable. Then each probability is between 0 and 1, inclusive 0 and 1, right? Their sum must be equal to 1. So let me write down. Okay, so I wrote down what I said earlier. Okay? Okay, now we have a discrete probability distribution. So assume you are going to flip coin 4 times and let discrete random variable x, the number of tails, this time tails, right? So number of tails, that you get out of 4 coin flips. Make a probability distribution for x. Okay, so we had the experience about the 3 times flip the coins, and then we made the tree diagram, right? So let's take a look. I don't want to do that, right? Because it takes a long time. All right, so let's take a look. This is from the book. So we have a head, tail. Yeah, that's the first coin toss. Okay, now there is a possibility we have 2 outcomes in head from the first coins, right? So head, tail again, right? Okay, then in the head again, so head again, third one, head again, tail again, and then head, tail, and so on, right? So we get all the outcomes for the first one, head, and second one, head, tail, and so on, and the last one, tail. Make sense? Okay, so we are going to create the probability distribution. All right? Okay, so I need this outcome to create. So let me just copy this one. Okay, make it smaller so that I can use the probability. Okay, so the first column about the capital X, number of tails, and second column outcomes, and then third column about the probability. All right, so X equal to 0, right? So X equal to 0 means no tails, because we want to know about the tails, right? So that means no tails. Okay, so in that case, we have H, right? Okay, now there will be probability. How do we get the probability? Probability of X equal to 0, number of tails divided by number of total, right? So total, how many total are there? 16 possible, 16 possible outcomes, right? So outcomes. So 16, how many tails in that case? Yeah, there is no tails, right? But then we don't put the 0, right? So this means no tails. So 1 out of 16. Make sense to you? This is the 1, means that there's no tails. We don't put the 0, okay? Yeah, don't get confused. All right, let's calculate. Can you please calculate this one? 0.0625. 0.0625. Okay, now second one, x equal to 1 means 1 tail. Yeah. Okay. So we have 1 tail. Let's take a look. Only I can see, right? Because too tiny. You can see this one. Yeah. Actually, I don't need this one. I can see this one too, right? Okay, 1 tail. So please correct me. I want to make it like that. Okay, so there will be H H H T H H T H, 1 tail, H T H H, and T H H H. That's it, I think. Yeah. Okay, so what's the probability of x equal to 1? So in that case, number of 1 tail is better, right? So number of 0 tail. Let me fix that. Yeah. Number of 0 tail and number of 1 tail over number of total, right? So there will be 1, 2, 3, 4, 4 out of 16. Now, can you please calculate 1 out of 16? 0.2500. Okay, good. All right, now x equal to 2 tails. So x equal to 2 tails. That means, okay, let me, yeah, I'm gonna use this one. Sorry, you cannot see. All right, so HHTT and HTHT, HTTH, and THHT. Oh no, no space. Oh no, I'm moving. Okay, hold on 1 second. There's more. Hold on 1 second. Let me fix that first. THHT and THTH and TTHH. Okay, so probability of x equal to 2, then number of 2 tails over number of total. Total 16, how many? 1, 2, 3, 4, 5, 6. 6? Yeah. Now, can you please calculate 6 out of 16? Number of 2 tails. 0.3750. Very good. Okay, so let us do x equal to 3. 3 tails. Yeah, okay. I need to make it smaller. Oh, I cannot see. Okay, let me try to see. Three tails. HTTT and THTT and TTHT, TTHT and TTTH, TTTH. Okay, so probability of x equal to 3. So number of three tails over number of total. So we have 16 total. How many three tails? 1, 2, 3, 4. 4. Then 4 out of 16, what do you get? 4 out of 16. So 0.25. 0, 0. Put the 0, 0. That's fine. All right. So last one, x equal to 4. Because we have 4 coins tossed, right? So okay, x equal to 4. So 4 tails. Let's see. How many 4 tails? Only one, right? Yeah. So tail, 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 tail. So x equal to 4. So equal to number of 4 tails over number of total equal to 16 is total only one. Same as the first one, right? 0 tail. Yeah. 0.0625. Okay, your turn. Can you please add everything up? Yeah. This column. Can you please add everything up? This column, last column. Do we get the 1? Because the sum must be equal to 1. Yeah. Sum is 1. And then every probability between 0 and 1 inclusive. Include 0, include 1, right? Yeah. So this is the discrete probability distribution. Yeah. Okay. Let's do this example. So it's the same probability distribution what we did. So we have probability distribution for x equal to number of tails in 4 coin flips, right? Okay, now we want to find when x equal to 2. Let's answer that. A. Probability of x equal to 2. So 0.3750, right? This one, they ask us how to read, right? Okay, probability of x, the capital letter. X equal to 2, I'm sorry. X is, X is greater than or equal to 2, right? So greater than or equal to means 2 means look, it's a discrete, right? Discrete, we have 0, 1, 2, right? So 2 is include there, right? Inclusive, include, yeah, include the number, inclusive. So that means x equal to 0, x equal to 1, x equal to 2, right? Same as. So there will be 0.0625 plus 0.2500 plus 0.3750. Now we calculate everything. So we get 0.6875. Okay, very good. Now see, what's the probability of x less than 4? Less than 4. We don't include the 4, right? So that means probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2. Oh, plus probability of x equal to 3, right? Let me make a 1 line. One line. Okay, so there will be, oh, what's going on? Oh, man. Okay, all right, so there will be, how about this? We have 0.6875 and then we just add one more, right? 0.6875 from B, and we add one more. So that is 0.2500. Yeah, 8. So, oh, can you please calculate? Is it 0.9375? Yes, very good. And we might think the complement rule, right? So what if we have more numbers, right? Okay, so we can think about complement rule. Let me write down complement rule. So we can think about probability of x less than 4 equal to 1 minus probability of, what's the opposite, right? Opposite phrase, number, or opposite statements. Let me just write an opposite. Yeah, so 1 minus probability of x is greater than equal to 4 then. Yeah, that's the opposite, right? Okay, now there will be 1 minus. Luckily, we have only one, right? Which is probability of x equal to 4, right? So there will be, sorry, no space. 1 minus 0.0625. Can you please calculate? 0.9, yeah, good. 0.9375. Yeah, this is the answer. Okay. What if we don't have this one? What if we have more numbers, right? It's better we are using complement rule. Make sense? Okay, very good. Okay, so we have the inequality statement and the symbol here, okay? So let's take a look. We have a less than, it's less than, right? So 3 less than word phrase is, okay, let me see. It's less than, it's fewer than, it's below. Everything is this symbol, right? Okay, now, is less than or equal to, is no greater than, does not exceed, is at most, is at maximum, is no more than. So we are using this symbol, right? One symbol. Yeah. Okay. How about is greater than? Exceed is above. We are using this symbol. And is greater than or equal to is at least is no less than, is no fewer than, is between exclusive, is between inclusive. So inclusive, we had that before, right? Inclusive means include the number, right? Exclusive, we don't include the number. That's why inclusive has equal sign there, right? And exclusive, no equal sign, right? Okay, and then let me write down later. And then I want to emphasize this one. At least we had the experience, right? So 5 stars, because we are going to use a lot in this course. At least means it's greater than or equal to, is greater than or equal to. That's why the symbol, inequality symbol like that, is greater than or equal to. At least means, yeah. Okay, so please remember that. And then, yeah. I suggest to you take the picture of this word phrase and then inequality symbol. So you can do homework, you can take the, yeah, study, right? Yeah. Okay, so let us do this question. Yeah, before do that, we check here with the inequality symbol. At most means it's less than or equal to, right? So let's make that inequality symbol here. At most, at least it's greater than or equal to, between 1 to 4, exclusive. So exclusive, oh, no equal sign, right? Oh, I did not write down. Let me write down. And inclusive, we include the number, right? So inclusive, include the number. Exclusive, no, not include the number. Yeah. Okay. All right. So at most, less than or equal to, at least is greater than or equal to, between exclusive, between there, but not equal sign, between inclusive, between there with equal sign. Okay, so let us do that. Okay, so we have a table there. Let's answer. So A part, what's the probability of X is at most 2 green light greater than or equal to 2, at most, sorry, less than, oh my gosh. Yeah, at most. Yeah. Then that means X equal to 0, X equal to 1, X equal to 2, because include the 2, right? At most has equal sign, less than or equal to. All right. Then what's the probability of X equal to 0? 0.077a plus, what's the probability of X equal to 1? 0.2592. What's the probability of X equal to 2? 0.3456. Now, can you please calculate? Okay, 0.6826, 0.6826. Very good. Okay, second one, we have at least 3 green lights. So at least 3 green light. X is greater than or equal to 3, at least. Yeah, at least greater or equal to, yeah. Okay, so greater or equal to, that is, yeah. Normally, when we see the at least, that is keyword, we are using complement rule. That's the 90% we are using that. But in that case, we don't need because it's in the middle. Yeah. Okay. So let us do that. Probability of x is equal to 3 because the 3 is included there, right? And plus probability of x is equal to 4 plus x is equal to 5. Yeah. Okay. So probability of x equal to 3, which is 0.2304 plus, what's the probability of x equal to 4? 0.0768. What's the probability of x equal to 5? 0.0102. Can you please calculate? It's a 0.3174. Excellent. Okay. Now, see. Between exclusive. So between exclusive 1 to 4. Okay, between 1 to 4, that means 1 is not included there, right? So we have to do 2, 3. 4 is not included. Yeah, that's it. So what is the probability of x equal to 2, which is 0.3456? What is the probability of x equal to 3? 0.2304. Can you please calculate? Which is 0.5760, right? D is inclusive. We include 1 and 4 then. So we have 1 and 4. And plus, copy. And make a little bit smaller, plus. Okay, so 1, which is, let me see, 1.0, sorry, 0.2592, right? 0.2592 plus, and 2, 3 using above, right? So 0.5760 from C, and plus probability of x equal to 4, which is 0.0768. So what you get is a 0.9120. Very good. Okay, so let us just take a look how to construct a histogram, right? Because we had the experience before. So same probability distribution for the 4 coins of flips, right? Okay, so this is number of tails, and then this is the probability y-axis, yeah? So this is number of tails. Number of tails. So 0, we have a 0.06, too tiny, right? So this is a 0.1, 0.2, 0.3, 0.4, 0.625, 0.25, 0.3750. We cannot draw 4 decimal places, right? We just approximate to 2 decimal. Yeah. And 0.25, 0.0625. Make sense? Oh, you cannot say, yeah, sorry about that. You cannot see what I wrote down here. Okay. Okay, now we have a formula for mean and standard deviation for discrete random variable. So we are using mu sub x, the capital letter X. So we read subscription there, so X, so mu sub X, right? Then look, we have the capital X and times probability, right? So that is the probability. Then by order of operation, we do that first, right? No, if I do that, then yeah, that thing that is do first. Then add last. Actually second, right? But I put the last. Do first, last, yeah? And standard deviation. We always have a, oh no, yeah. Normally we have a two equivalent standard deviation, but yeah, this textbook only the definition, the formula from the definition, the deviation, right? So yeah, only one. It's okay. Yeah, but then in that case, we have a two different but equivalent, the formula, right? Yeah, we can do either way. So equivalent. Okay. Find the mean and standard deviation for this one, right? Okay, so mean we are going to find together, right? And then standard deviation, the textbook has this one. So let us using this one, right? So let's try this one, second one, all right? Okay, so the mean, we make x times p, the probability of x, right? So let me make here the column. Okay, let me make it bigger, huh? Okay, so I wrote down this one, x times the probability, right? So 0 times that, which is 0, 1 times that, which is this, right? Yeah, now 2 times 0 0.3750, and you should help me too. So that will be 0.75. And then this one also 0.75. And this one is 0.25. Okay, now we make a sum, right? Yeah, that column. So summation of x times p over x. Can you please add everything up? Don't forget this 1.25 there, right? So that is 2. Very good. This is the mean, right? The mean of this probability distribution. In that case, it's a discrete number, right? Discrete random variable. Okay. So we have nice picture here. Yeah. So mean, which is average, right? So 2 there. Okay. Now let us do standard deviation. Okay. So as I told you, not StatCrunch textbook has this one, so you can take a look. And then we are using this formula to find out the standard deviation, right? Okay, so look, once again, multiplication. So we do that, this one first, then we add everything up, and then we can do this one later, okay? Okay, I need to calculate. So we have a 2 squared x squared. Probability is 0.3750, which is 1.5. We have a 3 squared times 0.25, which is a 3.375. And then we have 4 squared times point. Oh, no. I calculated wrong. Sorry about that. It's a 2.25. Sorry about that. 2.25. It's a 0.96. Yeah. 4 squared times 0.06, which is 0.96. Okay, we make a summation. The last column, x squared times p of x. So 1.5 times, add 2.25, add 0.96. It's a 4.96. Yeah. Okay. Mean was 2, right? So let us do that. Oh, let me using there. So we have equal to, or equal to here. So 4.96 minus mu was 2 squared, right? Okay, now can you please calculate? So square root 4.96 minus 2 squared. Yeah. So I'm getting 0.97979. I don't get the same answer with the earlier one. Let me double check. Okay, so this is correct. So 0.97, so 0.97979589. So they approximately make 1. And then I'm very sorry. I thought it was textbook has the first one, but actually textbook has this one. Yeah. You want me to show this one? I can show you in the class. Okay, sorry about that. Okay, so let's interpret this one. What this mean? Okay, so let's interpret. We have a mean. We just found earlier, right? So we found the mean is 2, and standard deviation we have approximately 1. Yeah, it was 0.9797958, right? So what this mean? We had the means that average, right? So average is a 2 standard deviation from the 1. This one telling us expect to get 2 tails on average, right? Because of this, right? Yeah. So that means, yeah, no, other way. Yeah. Expect to get the 2 tails on average. Each time we flip a coin 4 times, right? And then standard deviation equal to 1, telling us expected to be within 1 tail because 1, right? So if we have 2, then 2 is in the middle, right? So 1 and 3, we expect between the 1 and 3 tails. Make sense? So this means the standard deviation equal to 1, telling us to expect to be within 1 tail of the mean most of the time. Yes. Taken together, the mean and standard deviation tell us we should see between 1 and 3 tails because we have a 3 in the mean and standard deviation is 1, right? So, sorry, 2 is the mean. So plus 1, we get the 3 here. Minus 1, we get the 1, right? Yeah, that is a standard deviation. So, if we're looking at between, that means between 1 and 3 tails, inclusive, right? Inclusive. Between 1 and 3 tails inclusive. So between 1 and 3 inclusive, we add everything up. So that will be so means the probability of x is between 1 and 3. So there will be 0.25 at 0.375 at 0.25 again. So there will be 0.875. So we make 100 times percent. So we get 87.5% of time that you flip a coin 4 times between 1 and 3 tails. Make sense? Okay, very good. Sorry, you could not see my writing here. Yeah. Okay. All right. So I'm gonna show you how to use a stack crunch. Okay, so let us do this example. So in your statistics class one day, you learned there is a 51.8% chance that you will roll at least 1/6 if you roll 4 dice. Okay, so let me explain to you this one first. So note. So how do you find at least 6? Yeah, but then there will be at least complement rule, right? So 90% complement rule. So when you see that, complement rule. So there will be 1 minus opposite, right? Yeah. So in the dice, at least 6 means is greater or equal to 6, right? So, and means, at least means is greater than or equal to 6. But then in the dice, there is no greater than, right? So we are using only the equal to 6, right? In dice. Okay, then there will be 1 minus equal to 6. What's the probability of equal to 6? Then opposite will be no 6. Yeah, or less than or equal to 6. Not equal to, less than 6. We can say that. Probability below 6. How about that? Less than 6? Or think no 6. Yeah. That is okay. No 6. Yeah. Less than 6. Yeah. Okay. Then there will be 1 minus. We will get. So less than 6 will be 1, 2, 3, 4, 5, right? So there will be 5/6. But then they say that 4 dice. Yeah. So 4 dice. 4 dice. Okay, then this will be 1 minus 625 over 1296, then 671 over 1296, approximately 0.9177, and times 100%, we will get 51.77%, which is they say that 51.8%, right? 51.8%. That's how they got it, right? Okay. So we understand how they got 51.8% chance, right? At least 1/6 if we roll 4 dice. Okay, then you and your friend bet $5 that you will roll at least 1/6 when you roll 4 dice. Yeah. Okay. Now, what is expected? Oh no! Oh my God! I'm so excited to do this question, and then I did not explain the expected value. Yeah. So expected value is the same as finding mean. Okay. That's it. So we have mu sub x equal to summation of x times p of x, right? So that is mean of discrete random variable, right? So in other name, expected value. Yeah, expected value. There we go. It's another name for the mean. Yeah. Okay, sorry about that. Uh, so there will be, let me write down the formula. Okay, so mu sub x equal to summation of x times p of x. Yeah, okay? So anytime you are anytime you are asked what to expect, you are being asked to find the mean. Yeah, mean. All right. Okay, then make a nice table to find the mean. All right. Yeah, because we want to make a third column, x times p of x. That's the goal. Then we make add everything up, the last column. Yeah, that's the mean, right? Okay, let's do that first. Okay, so I made the table here. So outcome will be row 6. Okay, then how much money win? So $5, right? And the probability is 51.8%, which is 0.518, right? Oops, yeah, that is correct. How about don't roll 6? No, 6, yeah. So losing $5. Okay, what's the probability? So 1 minus 0.518, we get 0.482, yeah. Okay, so we have 5 times 0.518. Then what do you get? It's 2.59. And we have negative 5 times 0.482. What do you get? It's a negative 2.41. We make a sum, right? So sum of x times the p over x. What do you get? It's a 0.18. So this is the mean, right? So we have mu sub x. This is a mean. Also expected value. That is summation of x times p over x, which is 0.18, right? So let's interpret. This is on average, right? So on average, 0.18 means 18 cents. So you should expect to win on average of 18 cents per game you play. Make sense? All right, so let me write down. Okay, so we have a second part. So second part say that if you repeat this bet with your friends 100 times, how much should you expect to win or lose, right? So you win 18 cents, right, per game. Then 100 times, we times 100, then $18, yeah? So let me just read. Certainly not a lot for the many bets, 100 times, right? But we had a winning, the probability is more than 50%. So we had a 51.8%, right? So, but since the probability of winning and losing, so losing is 48%, which is almost half too, right? So very close each other. So you should expect to win only slightly more than you lose, right? Because winning 51.8%, losing 48.2%, right? Make sense? Okay, very good. Okay, so this question will be the last question for this section. So I'm gonna just read and explain with you the solution, okay? Because I don't wanna make a chart, each one. Okay, so let me explain. In a roulette, small ball is dropped into spinning wheel and comes to rest in one of 38 spaces. The potential landing spots for the ball are numbered 1 through 36 plus 0, 0, 0, right? Total 38 place spaces. There are 18 red spaces, 18 black, and 2 that are green. And that green are 0 and 0, 0. Okay. There are many types of bets player can make. Find the expected value of each $10 bet explained below. Yeah, everything is $10. Yeah. Okay. Which bet has the highest expected value? All right, so basically we want to find the mean, right? So expected value, it's mean, right? We talked earlier, which is mu sub x bar, that is gives us summation x times p of x, yeah? Okay, now let's read. I'm gonna show you, yeah. The first one, oh, I did not read the first one. The first one say that all three has different type. So first one has a straight up. I'm not sure this kind of a game there or not. Okay, straight up bet. They choose one of the 38 numbers on the wheel. If the ball lands on their number, they win $350. Oh. If the ball does not land on their number, they lose $10. So first bet is $10. They do that. They play game, right? win or lose. Second game, they play game again, $10. Yeah, that kind of game, right? Okay, so they bet their own number between 0 to 36 and 00, right? Yeah, or 0, 0, 0, 1 through 36, 36 spaces. Okay, then winning $350, losing $10, right? Okay, what's the probability? Any number they pick, 1 out of 38, right? They winning that, right? That number. Losing 37 out of 38, right? Okay, so 1 out of 38. Let me just calculate for you. 1 out of 38. That's 0.0263. That's 0.0263. And 37 out of 38. That's the 0.9737 round. Okay, so we multiply two columns, x times p of x probability, right? So 350 times that probability, then we get 9.2, and then negative 10 times 0.9737, it's negative 9.7. We make a sum of them. That's the mean, which is the expected value, right? So expected value. So let's interpret. Expected value is negative. It's negative means from my point of view, right? I'm losing, right? Player losing 53 cents per the game. Yeah. So should expect to lose about the 53 per the game. Yeah. All right. So let's take a look. Second one. Second one has different game. It's a red bet. They are betting the ball will land in a red space. They will win $10. Yeah, they mentioned in the beginning, $10 for each one, each game, $10. If the ball lands in a red space, we'll lose $10 if it does not. Okay, so red space, we had 18, right? So that probability will be 18 out of 38. Yeah, okay. So let's take a look at the solution. So 18, which is red, right? So 18 is a red spot. And then 20. Okay, so did you notice that? Black has 18 and then 2 are green, which is, yeah. They give it to the 0 and 0, 0, give us the 2 greens. So 18 plus 2. So there will be 18 black plus 2 green. Yeah. So 18 out of 38. Let me calculate it for you. 18 out of 38. So we have 0.4737 round, and 20 out of 38. It's 0.5263. Yeah. Okay. Then we times 10 times 0.4737. We move to the one decimal place, four time, not the four time, 4.7368, right? We have negative 10 times the 0.5263. We move to the one decimal place with a negative, right? So negative 5.2638, we make a sum, then that's the mean, right? So mu sub x. Okay, we have a negative means from our point of view, we're losing, right? So negative 0.526, the player should expect to lose about 53 cents per red bet game. Yeah? Okay, now let's take a look, third one. If player makes first dozen bet, they are betting the ball will land on 1 through the 12. They say the first dozen, right? If the ball lands on any space marked 1 through 12, they will win $20. Oh, $20 this time, not the $10. Yeah. I mean, the different. Yeah. If it does not land on 1 through 12, they will lose $10. So every game in here, they bet the $10, right? Yeah. Okay, so losing $10, that's why. They bet $10. If they don't win, they lose $10. Okay, so let's take a look at the solution, the first dozen, right? Game. All right, so amount to one is $20, lose $10. Okay, then 12, first dozen, right? The first dozen. Okay, 26, 38 minus 12 dozen, right? So they got 26. Okay, let me calculate this one for you. 12 out of 38. So it's a 0.3857 as of 8 round, and 26 out of 38, 0.6842 round, right? Okay, so they times 20 times 0.3858, then we got 6.3, and then negative 10 times 0.6842, we get negative 6.84. Make a sum, that's the mean. Once again, negative means lose, right? So the player should expect to lose about 53 cents per first dozen game, right? Okay, so let me read this one. The player should expect to lose the same amount, 53 cents here too, right? 53 cents, 53 cents here too. If there are 1,000 bets placed on roulette table, right? Then the casino make a profit $530. 1,000 times 0.53. Yeah. Okay. The expected value when not making bet is 0. So your best bet is to not make a bet in casino. Make sense? Okay. I wanted to try roulette. But yeah, right? Why we are doing this kind of stuff? Please don't bet in casino. There is no chance we are winning. Yeah, we're not uh, motivate you. We not encourage you to play game there, right? Make sense? All right, so please read yourself this one. Thank you for watching. I will see you in the next video. Bye.